Okay, hello everybody. Welcome to kubectl Plugins 101. I'm Jonathan Berkhahn. I work for IBM.
And I'm Carolyn Van Slyck. I work at Microsoft on the Azure Containers team, and mostly I spend my time upstream working on the Kubernetes SIG Service Catalog.
As do I. I'm also a core contributor to Service Catalog. Of course, it never works the first time.
Technology, why are you failing us? Okay.
Okay, so what are we going to talk about today? To start with, we're going to briefly cover the motivation, why we're giving this talk, who we are, why you should listen to us, that sort of thing. We're going to give a brief overview of what plugins currently are, how they work with kubectl, what that looks like. And then Carolyn's going to go over a bunch of simple plugins and some more complex plugins to show you sort of the problem space of what you can write, what you can do. We're going to go over some brief tips for writing your own plugin, and then we're going to talk about the future of plugins because it's currently under, like I said, active development. It's very much sort of in the works at the moment. Okay, so why are we here? Why should you listen to us? So we both work on Service Catalog, which is an extension project for Kubernetes. As an extension project, it implements a whole bunch of custom resource types, and it's kind of an older project, so it existed before CRDs were even a thing. So we have our own API server, our own resource types, our own controller, and it can be kind of cumbersome to interact with our resources using just kube create, kube edit, kube apply. So we wanted to implement some interface that people could use to talk to Service Catalog. How did we end up solving this problem? Carolyn had been already working on svcat, which started life as a standalone CLI just for interacting with Service Catalog. It has a whole bunch of commands, some of which are sort of re-implementations of Kubernetes commands such as Git, some of which have nothing to do with core Kubernetes commands. And we decided to turn that into a plugin. So it currently exists today. You can still use it in standalone mode, or you could install it as a kubectl plugin and have it live right there in kubectl with all your other commands. So, and to date, as far as we're aware, this is the first and only plugin that anyone in the Kubernetes community has written to actually attempt to perform useful work.
First post.
First post, best post. If anybody else out there has written one, we'd love to hear from you.
Yeah, please come up to the stage after if you've written a plugin. Or want to.
Or want to, but more on that in a minute. Oh, right. So that is what we are actually hoping to get out of this talk. It's really not so much for your benefit, it's really for our benefit. Our hope is that after today, you will go out, you will write your own plugin. It will be awesome. Now, this is good for a couple reasons. One, we're interested in there just being more plugins in existence so people can use them. That's a benefit to the Kubernetes developer community. It's a benefit to people who use Kubernetes if there's just more plugins that do more interesting things so people can use them. Reason two is that plugins are still under very active development. And we are currently sort of the only stakeholders. SIG CLI doesn't like us very much because we annoy them a whole bunch.
They love us. They love us.
So if we had more users, or more developers rather, of plugins out there, it would provide more feedback to SIG CLI on what plugins should be, what features they want, that sort of thing. So that would be super helpful. Yeah, so... Oh.
Sorry.
Okay, so what is a plugin right now? A kubectl plugin consists of two pieces. One of them is actually entirely optional. So we have some sort of executable and a plugin.yaml file. Really, you only need the plugin YAML file, but we'll cover that in a minute. So for the executable, it can be pretty much anything that runs. It could be a bash script, it could be a Golang executable, it could be a Ruby script, it could be pretty much anything written any way you want. It could do anything you want it to do. The one we've worked with mostly have been Go executables because they're part and parcel. They use client Go, that kind of stuff to interact with Kubernetes. But you could roll your own however you want. And it takes in a whole bunch of helpful information from the calling kubectl environment via these environment flags to let you know about what context kubectl was invoked with, whether people were invoked it with a specific namespace thrown, what were some environment variables. We'll go over that in a minute, but it takes in a whole bunch of information via these environment flags. And it lives in the .kube hidden directory with the rest of the kubectl stuff, like your config and all that. It just sort of hangs out in there. Right next to the YAML file. So the YAML file is actually the only required part of the plugin. It's a description of the various commands and their flags, and how to invoke them. So if you're doing it with an executable, this would be like /foobar command name. But you could just write a bash script inline in the YAML file, make a super simple plugin that way. So I'm actually going to hand this off to Carolyn, and she's going to give you some examples of how to do just that.
Yep. So I wrote the tiniest absolute plugin possible to show you that you can start small, do something fun. This is it, literally. And I actually use this, so it doesn't seem like, why would this be interesting? But so what it is I called my plugin flags. I have a little short description, and what it does is it basically dumps back out all the environment variables that kubectl feeds into your plugin to give you context about where you're running, what's the cluster, all that kind of fun stuff. And all the magic is on that command line right there, bash -c-env, and it's just dumping out all the environment variables. So I didn't even have to write a binary or anything like that. And then just for fun, I defined a flag so we could see what that looks like. So let's go in here and make this much bigger. Try this out. So if I type kubectl, plugin, flags, and let's just look at everything related to kubectl that it gave to me. This is all the magic that makes plugins work. I'm sorry. Yes, no, don't run. It's okay. So what they do essentially is kubectl parses every single one of the flags that was sent to kubectl in addition to the pieces of information that it grabbed from the context in your kube config and puts it into environment variables. They don't make the assumption that you are like a fully featured binary or executable that can handle flag parsing. And environment variables are kind of easy for everyone to grab and use. And it kind of passes all this stuff in. And so you can see like all my commands and a whole bunch of random stuff. And here's my local flag. Everything is prefixed with global flag except for anything you defined in your plugin YAML. And so you can see foo here. So if I had changed this a little bit and gone foo equals bar, you'd see that show up right here. So what does it take to actually distribute this as well? And this is kind of like, to be honest, the awkward part about plugins is that in order to distribute this, like let's take a look and let's like ls my my kube directory. Let's tree it actually, that's more fun. So I have a couple different plugins installed in Kube. I have a flags plugin that has absolutely nothing in it but that one YAML file. I have a kill plugin, which we're going to do next, and svcat, which has the svcat compiled Go binary, and it's plugin.yaml. And if you want to see something scary, let's take a look at what that looks like. It's just, yeah. svcat is actually an interesting thing, which is why we bothered to make a plugin for it. It also means that our plugin.yaml, which specifies every single command and flag that we support, is so hard to maintain that we actually generate it. And I'll talk about that later, how if you're writing something more interesting than the flags plugin, how to kind of keep up to date with something like that. So let's look at a real plugin that maybe demonstrates why you would want to try to make a plugin in the first place. So I wrote a little plugin, a killer plugin called Kill, and it doesn't do anything terribly exciting, but what it does, I don't know, it depends. If you're writing stuff with finalizers, it's very useful. So the deal with finalizers is that if I have, say, a pod, and I put a finalizer on it, and then I try to delete it, I do kubectl delete the name of the pod, it actually won't delete until that finalizer is gone. And that can kind of be annoying. And you're like, okay, fine, kubectl edit. That gets old really fast. And I think this is kind of the point of plugins, is that you don't have to be a SIG. You don't have to be some like advanced developer or be doing crazy things. It could just be, here are common things that I do, and normally I put into a bash alias or a helpful script or anything like that. You can actually put directly into kubectl. And the reason why you may want to do that is to share it with people, because this is probably a useful thing to do. So I wrote a plugin called Kill that takes in a grace period and rips off any finalizers, and don't use this in prod, but in dev, it's very easy, useful. So my kill function, this is all Go. I load up a client, and I'll show that in just a second. And what I do is I just use the regular client Go, and I delete all the finalizers, and then I nuke it. Not terribly interesting there. And so this is what it would look like. So let's take a look at all my pods at the moment. And I'm going to destroy one of them. So I'm going to do kubectl plugin, and this time it'll be kill. And I'll just put in the name of this pod. And let's make sure that's big enough. It took off any finalizers that were on that pod, and then tried to kill it, and completely got rid of it, and didn't wait at all, because we called it kill for a reason. So there's a couple things when you're writing a plugin, especially if you go through the Go way, that you're probably going to end up wanting to do pretty quickly. The first thing I ran into was that we use glog in the client Go library. And if you're familiar with glog at all, you know that it doesn't handle flags maybe as gracefully as you wanted it to. So if you're curious, what is the special to arcane commands to be able to maybe get debug output from your kubectl plugin, very helpful to say, like, dump out all the different HTTP requests and responses. That's it. Don't ask me why, but that's what makes glog work. And then after that, inside my main, I parse my flags just like I normally would. And what I'm demonstrating here is something that just works as a plugin, but our more advanced one actually works in standalone mode too, and I'll show that in a second. So my pod name, which was my first positional argument, I can just grab off and use for my OS args. But kubectl kind of gets in the way of everything else, very helpfully gets in the way of everything else. And instead of having a flag for grace period, I grab it off of environment variable here. And then I go to kill my pod. So this is where we're trying to build up a greater library of things to help you make plugins. So this is something that Jonathan wrote. It's in upstream Kate's kubectl. It's called plugin utils. And it handles grabbing all of those various global flags. I mean, you saw the list. It was quite large. It goes, not all of them, but all the really important ones. It goes through those flags, parses them, and then gives you a kubeconfig that you can use to then load up as a client and start doing what you cared about doing. So for my little kill plugin, this is all I had to do was say init client and config, and then make up my config object, grab off the current namespace. The reason why that's important is because not everyone uses -- namespace. Sometimes it's set on the kube context itself, so this is where you get that information. And over time, we're hoping to build this up so more common tasks are ended up being shared with everyone who are writing plugins. So let's take a look at svcat, because it does a heck of a lot more than any of these plugins. You can run it in plugin mode, so this is what it would look like. kubectl, plugin, svcat, get. We have brokers. It doesn't matter. And it'll print out nicely formatted information for you at that point. I think Jonathan is the only one who insists on running it as a plugin at the moment. We're actively working with the SIG CLI to improve what this looks like, and in the future, it will be much nicer. It'll probably just be kubectl svcat, or maybe even something more brief than that. But what most of us do, is we just use the binary directly. Get brokers. So a couple of things that Service Catalog has is the ability to have a connection between your cluster and whatever the cloud surfaces are of the platform that you're running on. So maybe I'm on Azure, I'm on Google, I'm on IBM's thing that I forgot the name for, sorry. You can list out all the different capabilities and as-a-service things that you can provision. So if I do get classes, on this cluster, I can provision the best databases there are. This is actually from MiniBroker, which if you saw Jeremy's talk is the best broker. And it runs inside your cluster and just provisions things as containers. And it's very useful when conference networks are a little shaky. So this isn't terribly interesting, like get classes. It's like, well, big whoop, I could have done that with kubectl. I could have gone kubectl, get cluster service classes. We have very verbose resource names, which is one of the reasons why we wanted this. It's not quite as helpful, but you're like, oh, that's not so bad. Why did you write a plugin? So let's do another one. Let's do svcat get bindings, which is another thing. And I'm showing a whole bunch of information, and like that ready, you won't find if you look at our YAML or JSON output. Like you need to do a little bit of logic to get to that, and there was no good way for us to shoehorn that extra information to look at all the different status conditions on a binding and come up with one friendly little word to tell you how it's doing. Another example is if I go to describe this binding, we'll do MyDB. So bindings are associated with secrets. And so in this case, we have a secret on the cluster named MyDB. But like the 99% case of what I want to do when I'm looking at a binding is actually figure out, well, what are the keys within the secret? And possibly decode it and see what's going on there. So this is another example of where kubectl doesn't quite get us where we want to go. We'd have to execute multiple commands, and it's like a number of commands and then base 64 decoding every single one of those keys. And no one wants to do that. I certainly don't want to do that. And so this will just allow you to do a bunch of commands, like a porcelain command in Git, and let you bring that all together. So we're working with SIG-CLI to kind of figure out a better way to make all this happen, but hopefully you see like the value and why we did this. One more ugly I can show you, because who doesn't want to show all the ugly? Is kubectl, like they say you wanted to see everything about it, like this describe the equivalent. If I do describe service binding, MyDB, I get some of this back, but like going through this is kind of awkward and not terribly helpful. And eventually we'll get more control over the formatting, but at the moment, the usability experience for this was really hurting us onboarding people onto our project. So we were pretty motivated to make a better experience than that. Oh no, what happened? Oh my gosh, thank you. Nope. Abort. Dude, what happened? Where'd it go? Save me. Keep talking, man.
Okay, so
Seriously?
So, and that version of svcat that we showed is actually, it's still in active development, so that, you know, we have, I don't know, I think it's like around a dozen commands at this point. We're still adding more every day, because not only are we adding commands to interact with these independent resources that we added, brokers and classes and all that, we also want to add sort of meta commands, things that wouldn't really make a whole lot of sense as core Kubernetes, like extensions of CRDs. So for instance, the service catalog has this sort of notion of a marketplace, which isn't directly tied to a single resource type. It's sort of a notion of like, what services can I buy on this thing? And it's sort of an amalgamation of brokers, classes, and plans. So we want to be able to have our own command that sort of provides information about all of those things in one sort of helpful to find place.
Yeah, cool. So we've brought it back. I just wanted to mention a couple of the lessons learned from building out a plugin for svcat. One, the controversy is that we're using it as a standalone binary probably more often than people use it as a plugin. SIG-CLI is working, if you went to their deep dive, you got to see kind of their plans for the future, making things either closer to Git-style plugins or actually moving a lot of this logic into the server so that kubectl could dynamically discover endpoints on the server and then execute that. And that's where a lot of the code execution would happen on the server side, and then just bringing back output to the client, so that instead of having to install a plugin and then have use it, you'd be able to offload more of that into a centralized place so that it's a little better UX. Otherwise, a couple suggestions. I'm sure you noticed that we use verbs like get and describe. When we do things like that, it was on purpose. It wasn't to confuse people. It was to provide a pathway, a migration path, to when eventually svcat isn't a standalone binary. And maybe in this wonderful future, you could type kubectl get classes and use the output that's coming from our plugin, was the hope. So we didn't want to have any of the flags or the syntax or the output vary too much from what kubectl does today. And then you notice a lot of the output looks very similar. One of the things we'd like to work with SIG CLI is to bring some of the printers and export a little bit more of that logic so that we can make use of it inside of our plugin. At the moment, we're just being really good at mimicking what it looks like for the most part. And then otherwise, I do recommend avoiding replication of kubectl's core functionality whenever you can, so that as the plugin model evolves, you don't end up having written some sad amount of code that is going to be deleted when eventually we have a proper plugin experience in kubectl. I want to go over a couple of the gotchas and tricks that you need to know when you're working on a plugin. One, as I mentioned before, I'll type in at the command line all of these different flags, and they're coming to me as environment variables, which is fine depending on what you're doing. But when it comes to doing things like loading in all my configuration, that can be a huge pain very quickly. So I definitely recommend use Jonathan's plugin utils for a consistent way to load up your client, have it handle all of the flags, and figure out what the current namespace is so that you're not rewriting a lot of logic out there. And then otherwise, if you're trying to write a plugin, if you're anything like me, you immediately want to use Go. And then if you're anything like me, you immediately go, like, Cobra is the best thing ever. And if you're not, like, tell me what you're using. So Cobra is one of the libraries in Go that handles flag parsing. It's a higher level one built on flag. And it allows you to not have to write yourself, how do I parse dash dash equals or dash dash space, whatever. So here are two functions that we use to allow us to handle running in plugin mode and running in standalone binary mode. So I have this handy little function called isPlugin, and it just checks for the existence of an environment variable, and then I know no sane person would ever have this on their machine, so I'm probably in plugin mode, hopefully. Yeah. And then otherwise, bind environment variables uses another library that was also written by SPF13 that handles basically all the configuration you'd ever want to do. It knows how to handle configuration files, environment variables, and flags. And this is the magic glue that smooshes it all together and feeds it into your standard Cobra stuff so that none of our other code is aware that it's a plugin. So there isn't a huge overhead. I wrote these two functions, and ta-da, I'm a plugin. So again, glog is silly. You need to do a little bit of fiddling to bind glog's information. And then otherwise, VIP set environment prefix. VIP is for Viper. All of my flags are going to come prefixed with local flag, and this is what you use to tell Viper, hey, my flag may be called foo, but when it comes in as an environment variable, it's going to be kubectl plugins local flag foo, which is a mouthful. And the last bit essentially rips through all of Viper's configuration and applies it to Cobra. And at that point, once this is run, you're free and you don't have to worry about whether or not you're plugin anymore. Otherwise, the biggest kicker that I ran into when I first started writing plugins is that there are reserved flags in kubectl. You know what they are by writing kubectl options that will list out a big list of all their short flags and long flags for you. If you happen to use one of those and define it in your plugin.yaml, it will just not load your plugin, and it won't tell you why. It doesn't matter how high you set for both. You will not know why it didn't load your plugin. So just avoid them. The common ones that you may have had because you were running in standalone mode is context, config, -v for verbose, -n for namespace, stuff like that. So I have a little bit of extra logic that strips this out before I code gen that plugin.yaml. And then the last little gotcha, but don't worry, I have an open PR for this, is that it doesn't handle Boolean flags yet. A Boolean flag is where you can just go -- name of the flag, and you don't say true or false. Its existence means that that flag is true. If you're running in plugin mode, it's actually going to pass it into as a string, and it's going to be true, and that's what you need to use to make it work. So if anyone in SIG CLI is here, merge my PR. Okay. Yay! Okay, please merge it.
Okay, so now's the part where I come back and scare everybody out of the room. So everything we've talked to you about today, technically speaking, is still in alpha. Now, what does that mean? It means it could cease to exist tomorrow. No. So the current plugin architecture is in alpha. However, plugins as a concept are here to stay. So the SIG CLI, generally speaking, they're pretty sure they want plugins to be a thing. What that means may change. The current proposal is to move towards the Git plugin model, where if you call kubectl with a command name that it doesn't recognize, it looks through your path for some binary named kubectl-command name, and if it finds it, it calls it. What does that mean? That means that if you wrote a plugin today under the current model, as long as you adhered to keeping it a binary, making it not steal one of the names of a core command, it would be fairly easy to transfer. So our hope is that that doesn't scare you away from writing plugins, because, like I said, we need more users, we need more developers, we need more people participating in this ecosystem. Carolyn mentioned that she has a PR open to fix the Boolean flag support, so hopefully you'll be able to use those in the very near future, as well as supporting all of the global flags in my plugin library. So I think we have a link to it on the next slide.
Yep.
Yeah, we'll get to that in a minute. And then, yes, the base recommendations.
Yes, I have some controversial recommendations that no one may agree with other than me, but since I wrote SVCat and it's the only plugin, I get to make the recommendation. I really strongly suggest that I know that they give you all that nice magic with the environment variables, but honestly, as soon as you start writing anything that isn't even remotely trivial, you're probably going to end up wanting to write just a standard binary, and obviously Go, because gophers. So I recommend going down that path, because some of the other ideas that they've been kicking around are either all server-side anyways, at which point you would have written it in Go, or like the Git style plugin, they're going to be calling out to a binary at that point anyways, and you're handling your own flags, and you won't be getting all of those environment variables given to you for free. So prepare for the future, and hopefully you won't have to rewrite a ton of code. And then otherwise, don't name your plugin after a command that's already a kubectl verb. Because eventually, right now you run it, you say kubectl plugin svcat, but eventually that plugin subcommand that we're using during alpha will go away, and if you collide with an existing verb, guess who's going to win? It won't be you. So don't make a plugin called logs. Of course.
Yeah, so just one more thing I want to mention about this page. Feel free to download our slides. The link there on Git plugin models, a link to the current plugin proposal. And like I said, we're looking for more people who have comments. So please download the slides, read the proposal, say you like it, say it stinks. I don't know, whatever. But we need more opinions.
Totally.
Okay, so these are just a couple links to resources for writing plugins. The first is just a link to the kubectl documentation about what a plugin is. The second is a link to my library. So this is the library I've written just kind of to help myself. When in the process of writing svcat, whenever I need to parse some new flag that kubectl passes to us rather than just writing it and sticking it in our code base, I've been attempting to extract it into a Golang library that is generic and can be used for any plugin for anything. So currently we have support for most of the big ones, namespace, context, config, but there's like 100 and something flags that get passed in, so I'm just adding them as I go along. Hopefully, if you want to write your own plugin in Go, it should be super helpful to you. So yeah, check it out, see if you can use it. If there's something you don't need, feel free to submit a PR, bug me on GitHub, I don't know. And then, do you want to talk about the next thing? Because you wrote it.
Yeah, I do. So one of the things I was recommending to you was, I'm a shill for Go. You write your plugin in Go, use Cobra. If you go down that path, and you end up writing something complicated enough that manually generating that plugin.yaml file is a huge pain in the butt. My threshold is like one command, and then I'm not willing to do it anymore. I have a little library that's inside of svcat that's exported that you can use. It's just 2 lines of code where you can give it your Cobra command, the root command for your entire app, and it'll generate the plugin.yaml for you, and then you can just write it to the file system. So don't rewrite that. It's already out there. So I wanted to come up with a couple ideas for what you could do to write a plugin, because this fell in our laps. We were SIG CLI or SIG Service Catalog. We needed a CLI, and so it kind of forced us to go down this path. If you're writing CRDs and you have maybe custom verbs or porcelain commands that combine multiple actions into one, or you want to just totally go hog wild on your output or hit external services, all these kind of things that just tweaking what kubectl is showing won't be enough, a plugin may be a good thing for you. The plugin that I was totally going to write on the plane, but then I slept, who knew, is the wait plugin. And this is an example in my mind of something that is incredibly useful. I just deployed something, and it's a deployment. And I use kubectl to deploy it. Now I just need to wait until it's ready to use and available. I don't know if you have the magic bash for that works every single time, send it to me. But otherwise, goodness, I just want -- wait. So the plugin is going to be kubectl plugin wait, and then the name of my deployment. And whatever magic bash scripts I use to set up clusters and install my software, I will use that immediately. So maybe next week this will be posted. And you can use that. Otherwise, anytime you're running a bash alias or crazy functions, you can turn it into a plugin, and you don't even need to do the binary part. You can just shove that into the plugin.yaml, put in whatever magic commands you need, and you can share it with people. Another idea is a troubleshooter plugin. So let's say that you're writing some application that runs on top of Kubernetes, and it's more complicated than a single service or a single deployment, and health checks are individual on each one of these components, but I'd like to see for an entire cluster where my application is installed, why is it not working? Having something that can run through a series of health checks, sanity checks, and identify actually, I scraped your log for your API server, and I found this message, which means this. You need to fix that. Or, oh, DNS is down, something like that. These are useful things that normally people would either just write in a wiki somewhere, and having that just be an instant, I found the problem with your cluster, is incredibly useful, and for every bespoke piece of software, you could have a plugin for it to do that. You want to talk about plug and play?
So these are just a couple more ideas. Having a plugin that would let you record and replay macros of pre-existing kubectl commands. So I know a lot of us probably have workflows of these 5 things we always do in a row, targeting a certain context, all that. This would just be something that would be helpful to help automate that in a way that's more reproducible than a bash script. And then my thing I was going to write on the plane here and ended up not getting it was actually a plugin. So currently, SIG CLI does not have any plans for any inline way to discover or install plugins. So I was going to write a plugin to do that. So I can see SIG CLI shaking their head.
Yeah, it'll be kubectl plugin, install my plugin, please, plugin.
It's going to be great.
Yeah, plugin. That's all we have. Thank you very much for coming. And if you have any questions, we've got a mic we can pass around.
Right. I guess I'm supposed to.
I don't think it's on. Oh, it's
there we
on.
go.
So I got a little bit confused. You have a model reading plugin into Kubectl, and then you had a separate svcat tool. And it sounded like you were recommending the svcat tool.
Yeah, so I wrote a standalone Go binary, and I drop it inside of the kubectl plugins directory. I have 2 ways of executing that. One is I can just type svcat and use the binary directly. Another, I can use it through the kubectl plugin architecture. Right. At the moment, because the architecture is in flux as it is, most of the developers choose to run it in standalone mode. But long term, we want it to be 100% plugin.
Yeah. So the reason I brought this up was, from a developer's perspective, I totally get that. I totally see that. From an end user perspective, and we saw this mistake in OpenStack where each main component had its own different command line client tool.
Yes.
Huge disaster from impacting usability. People could not learn how to use all the components. They literally had to build a new OpenStack client that unified that all back. So I know from a developer's perspective it feels good to do that, but somehow that has to kind of go away quickly, because what that does to your end users is just brutal. Not if there's just one, but wait, let's say 3 or 4 other projects do that, and you will have the biggest usability impediments that you've ever seen. And so please don't reinvent old mistakes.
Sure, and I'm 100% aware of this, and we've seen this in other avenues as well. The reason why we are is because plugins are alpha and the usability experience isn't there, and that's why everything about the binary is written to as soon as it can support what we need, we're going to get rid of standalone mode and only work as a plugin. Because ideally, what I would love to see, and I wrote an experience report for this and gave it to 6CLI, is I'd like to be able to say kubectl get classes, and you're never even aware that you're going through my plugin, and you don't switch between binaries, and you're able to see my specially formatted output that may have had slightly additional information brought in. At the moment, this is the only viable path to making our plugin, though. Yeah, but I agree with you.
I think we're actually out of time.
All right.
So thank you all for coming.
Thanks, everyone.
We're going to be available for more questions if you have them. Please come up to the stage and we can have a chat.